In the previous two exercises, you implemented all the steps of principal components analysis on your own, computing the covariance matrix, taking its eigendecomposition, computing the component scores, normalizing the eigenvalues to percent variance explained, and so on. And here, the purpose of exercise 3 is to implement a PCA in Python using scikit-learn. So you want to find the method in the sklearn.decomposition library, and basically you want to figure out how to use it. Now, I'm not going to just tell you how to use it, because part of the reality of using Python is that you will have to spend time figuring out how functions work and how modules work, and just various things that you want to implement in Python. And so I think if you read a book or follow a course where the instructor tells you exactly everything you need to type in every single case, you never need to look up anything on your own. Yeah, I don't think that's really preparing you for the real world. So I try to do a little bit of a mix of giving you hints, guiding you in the right direction, and also letting you develop the skill of looking up, reading doc strings and reading up, things online. Anyway, so PCA done in scikit-learn, and basically you just want to show that the results match your manual PCA that you have implemented in the previous two exercises. So the function is called PCA, not so surprising. And basically it works as follows. So this is a class. You have to create an instance of the class, and then you apply this method called fit_transform to the data. And notice here, we are not using data matrix X. You can, of course, you can also input matrix X. But what I'm illustrating to you here is that these data are non-mean centered. So the PCA method will actually mean center the data for you. So in practice, when you are sitting down to do principal components analysis, if you want to use scikit-learn instead of implementing it on your own, you don't need to worry about mean centering the data. This does all of that stuff for you. Okay. And again, we don't need to go through all of PCA, all the steps, all the visualizations. It suffices to show that the eigenvalues that we computed match this variable here called explained variance, which is contained inside this PCA object. And then also the first eigenvector, which we know will match the singular vectors. And then you can compare that against PCA.components, and then we want the first one again. Okay, so run these, and you see yet again, these all match perfectly. So this all looks great. And then, in the book, I have a short discussion about when you might prefer different methods. It's really up to you. I mean, this is pretty convenient to use this method, but sometimes it gives you more flexibility to be able to write your own code, to have the knowledge to write your own code and your own methods. That is for you to decide. What I think was my responsibility here was try to guide you through all the linear algebra math underlying PCA, and I hope you feel that you have learned something about that.